Anyway, I'm Godfrey Boyle from the Open University. I've been there for a very long time, working on teaching and researching in renewable energy. And Brian's asked me to talk about Zero Carbon UK. And by the way, I'm here very much interested to listen to Zero Carbon Ireland, but there may be relevant lessons in what's been happening to work on the possibility of Zero Carbon UK. So I want to start off with a scenario produced by the people at the Centre for Alternative Technology in Machynlleth that some of you may know, called Zero Carbon Britain a couple of years ago. Then I'll be looking at some scenarios produced by the UK Energy Research Centre, which is a consortium of universities funded by the research councils. I'll be looking also at the UK government's low carbon transition plan, which envisages an 80% cut in carbon emissions by 2050, and similarly at the UK Climate Change Committee, which is an official body set up by the government, which has shorter term targets of 34% cuts by 2020, 80% by 2050. And then I'll be looking finally at the Zero Carbon Britain people at CAT haven't stood still. They're revising and improving and refining their scenario, and they're currently working on Zero Carbon Britain 2, which will be based on one of the UK Energy Research Centre's scenarios called DREAD, for reasons that are rather obscure. And nothing to do with long hair and dreadlocks. And finally, I'll be looking at showing you a small video from Germany, which shows how variable renewables can be integrated and provide the energy requirements of, or the electricity requirements of a country like Germany in a satisfactory, technologically feasible sort of way. And then I'll be trying to draw some tentative conclusions, but the conclusions will be very much open to modification by the discussions and debates that we have both today and online. So this is the Zero Carbon Britain Mark I scenario produced by the people at CAT a couple of years ago. It was deliberately an Ireland-Britain scenario. They didn't allow for any imports and exports. They adhered to the well-known principle of contraction and convergence, that throughout the world, the high carbon emitting nations need to come down in their carbon emissions, and the low carbon emitting ones can come up a bit, but we all need to converge on a very low, if not even zero, emissions of carbon over a fixed period of time. They chose a very ambitious target of going to zero carbon in only 20 years, from 2020 to 2020. It's 2007 to 2027, and even they called it mapping the unthinkable. So it is an unashamedly challenging and ambitious scenario that they produced. You can see this budget that they outlined in the bottom graph. They used a system, or they proposed that Britain should adopt a system of tradable energy quotas. That would mean that everybody would be given a personal carbon allowance. And if your carbon emissions were lower than that, you could sell your carbon allowances to more extravagant people. And equally, if you were an extravagant carbon emitter, you would have to buy carbon allowances from somebody else. Well, there are some pros and cons and pluses and minuses of that system which we could discuss later, but that was what they decided to settle on. Is this a point? Yeah. So I don't think I can already look. Right. So this shows the way in which they proposed to do that. They had a scenario of what they call power down and power up. By various energy conservation methods, they would reduce the UK's final energy demand to approximately half what it currently is at the moment. The measurement of that starts to get complicated depending on whether you're talking about primary energy or delivered energy or electricity. Again, we don't want to necessarily get into that right now, but we could later, so the statistics are a bit confusing at times. But as you can see from this graph, they reduce the energy demand to something like 1,300 terawatt hours by 2027, and they crank up all the, they phase out fossil fuels. They leave the existing nuclear power stations to gradually die out. There is a tiny bit left at the end, I think. And they crank up particularly offshore wind power. That becomes a tremendously large contributor, something like 460 terawatt hours of the 1,300 altogether. Whether that's feasible or not, we can discuss in a minute. And the way, in electricity on the other hand, although the overall energy demand is reduced in the scenario, electricity demand is actually almost doubled, partly because of the increases in electrically powered transport. They shift a lot of transport to electricity using batteries and electric cars. And also in buildings, they use air source and ground source heat pumps, which are electrically powered, to provide the heating that would otherwise be provided by fossil fuels. And they also introduced a smart grid with demand management, so that, for instance, if you had a fridge, for instance, you have a smart controller that would sense, possibly through sensing mains frequency, whether the grid was overloaded or not, and it would turn your fridge off for 15-20 minutes, which you wouldn't notice, but it would mean that the grid was substantially deloaded if that was done. And you can see where, in this graph, how the variation in the outputs of the various renewables matches the demand. The demand is the dotted line going across. And there's a tiny deficit around the middle of summer, but not a big one. And as you can see again, an awful lot of the energy comes from offshore wind. We can discuss, you could possibly park on one side any reservations you might have about the feasibility of that until later, but we can, I hope, discuss in great detail, if necessary, how feasible it is to crank up offshore wind really fast. This shows how they propose to reduce energy demand for heating in buildings. And as you can see, they propose to approximately halve buildings' heating demand in both the commercial and the domestic sectors. But they would also, the electricity demand of buildings would be about constant or maybe even slightly increase because of the increase in use of heat pumps that I mentioned. And therefore they use electricity. This shows how the supply and demand balance for heat would vary, and as you can see, the heat demand obviously is particularly with highly insulated buildings, goes right down in the summer to a very low level, and that would be met by a combination of combined heat and power, much of it, in fact ultimately all of it biofuel, heat pumps and solar thermal energy sources for the heating of buildings. I hope I'm not trying to gloss over these things. I mean, there are huge amounts of detail that one could go into in all this. I want to give you a quick overview first. And this gives you an even higher level overview, just to show that they have done their sums. Those of us who work in energy a lot are very familiar with the Sankey diagram, which shows how the energy flows in a nation's economy from the inputs to the outputs, to the waste sinks. And this shows that they've done their sums, that the sums in zero carbon Britain do add up. You can challenge the assumptions upon which they're based, of course, but the inputs and the outputs do finally add up to well, zero. Now then, I want to switch to a more, perhaps, acceptable. I mean, the Centre for Alternative Technology has been long out there on its own, pioneering a very green approach to energy, and it takes a while for the establishment to catch up with these things, as I'll be showing you in a minute. But the UK Energy Research Centre is a highly respectable organisation funded by the Research Councils of Britain, involving several universities. And in 2009, they published their Energy 2050 scenarios. There were a very large number of them. They used an energy modelling system called MARCAL, which is devised by the International Energy Agency. And it's again a very well recognised and accepted energy modelling system that takes into account market pricing as well as the feasibility of energy technologies, and takes into account demand as well as supply and so on. And they also, as an aside, they looked at not just zero carbon, but the resilience of energy scenarios. And for instance, how susceptible is an energy future susceptible to, for instance, the Russians cutting off a gas pipeline, or an Arab oil embargo, or a Chernobyl nuclear accident, or whatever it might be, or a war. So that they tried to see how resilient the various, and there were many of them, scenarios that would be in the future. Most of the scenarios I'll show you in a minute were able to achieve an 80% reduction in carbon by 2050. And they have these 4 core scenarios, which I'm showing you here, and then there were various variants. The DREAD scenario was a peculiar title that I'm not quite sure why they chose that, but I think it was to do with the sort of slightly tongue-in-cheek title to imply a dread of nuclear power, which is true. Now, as you can see, these were the 11 of the scenarios that do achieve an 80% cut by 2050. There's a whole host of them. The ones I'll be concentrating on the bottom 4, bottom 3 rather, DREAD, ECO and NIMBY. In fact, I'm only going to be talking about the DREAD scenario because the ECO and the NIMBY one impose constraints that the CAT people, the Centre for Technology people, don't consider to be desirable from their point of view. Whether or not you agree is entirely up to you.